Okay, this is a big deal in sequences, and it's the idea of the partial sums of a sequence. This is kind of interesting. For the sequence A1, A2, A3, A4, all the way to AN, the partial sums are, suppose S1 is the partial sum of just the first term. S2 is the sum of the first two terms. S3 is the sum of the first three terms. S4 is the sum of the first four terms. S5, first five terms. Sn, the first n terms. Those are what we call the partial sums. But then if we look at those partial sums as its own sequence, then we get S1, S2, S3, S4, S5, all the way to Sn. That's called the sequence of partial sums. Okay, let's understand what's going on. First off, this is we can define a sequence using this formula. An equals 2 to the n. So I'm asking you the first four terms. Well, we could have A1, right? Let me write A1 here. A1 is equal to 2/3. What's A2? Well, A2 equals 2/9. A3, what's A3 equal? Well, that equals 2/27. So we could do this, right? And so we have this sequence, we could go A1, A2, A3. But I'm not asking for the first four terms, I'm asking for the first four partial sums, okay? All right, well, how does that work? Well, S1 is defined to be A1. In this case, A1 is 2/3. S2, what I do is I take the first two terms and add them. S3, I add up the first three terms. S4, I add the first four terms. And so forth. Sn, I add up the first n terms. So it asks me, first of all, it asks me to find the first four partial sums. I did them, but I don't have them all calculated, do I? Except for this one. That one's easy. Okay, good. Well, you can use your calculator if you want. In fact, I think they have fraction buttons on them. Let's see, mine does right here. And if I write 2/3 plus 2/9, I get 8/9. Nice. And you'll notice something to make this easier on you. That's 8/9, therefore that's 8/9, right? So to get the next one, I'll just take that 8/9 and add 2/27. Good. So this gives me 26/27. Good. Well, so then S3 is these first three, so I know that this is 26/27. So I just add 2 81s to it, plus 2 81st. 80/81. So if I start looking at this as a sequence of partial sums, so if I have S1, S2, S3, S4, eventually I want Sn. The first one is 2/3. The second one is 8/9. The third one is 26/27. The next one is 80/81. And I want to get, what's an expression for that nth term? Well, do you see the pattern? Look at the bases. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. What's the next one probably going to be? 3 to the fifth. The fifth term is going to have 3 to the fifth. The sixth term is going to have 3 to the sixth. The nth term is probably going to have 3 to the nth power, isn't it? First term, 3 to the first. Second term, 3 to the second. Third term, 3 to the third. Okay, fine. So we got the denominator, but what's the numerator? Well, isn't the numerator always just one less than whatever you had for the denominator? Well, what's my denominator? Well, it's 3 to the n. We'll take that 3 to the n and do what to it? Subtract 1. That's your numerator. Okay? So, we just found the nth partial sum of this thing, okay, by kind of looking at each partial sum, writing that down as a sequence, and then seeing, hey, what formula matches up with this, right? Okay. All right, last thing we're going to talk about is sigma notation. What is sigma notation? Well, this is it right here. It looks really complex. The only reason it looks complex is because it's new. Okay, it's not a difficult concept. Okay, what this sigma is, that's a sigma. What that means is sum, right? So we're going to sum from k equals 1 to n of some formula. What that means is, this is called the index, okay? Index goes starting from 1, it ends at n. So we put in 1 here, we get the first one, plus, this means sum. Then we put in 2 here, and we keep going until we get to n. This should be n. So put that. Typo. Okay. So, writing this down, I know it seems totally nuts. What the heck is all this? But if we look at an example, you'll kind of see it's not that bad. So what does this example mean? It says, I want you to find sum from 1 to 4 of k squared. That's my formula. So we first put in k equals 1. And we get 1 squared. 1 squared, of course, is 1. Awesome. Then we write plus, because sigma means sum. And then we go k equals 2. We go from k equals 1 all the way to k equals 4. We did k equals 1. This was k equals 1. Then we're going to do k equals 2. All right, find k equals 2. We put 2 squared in there, I get 4. Plus, now we'll do k equals 3. Put in 3 squared here, we'll get 9. And then finally, k equals 4. I stop there because I'm only going from 1 to 4. K equals 4, 4 squared. And so I'm adding this up, and I think we get 30. Okay, so this is 30, right? That sum equals 30. Again, it's a sum of k squared. It's where k is going to be 1, k is going to be 2, k is going to be 3, k is going to be 4. Here I want the sum of 1 over k's, where k goes from 1 to 3. So my first term will be 1 over 1 plus 1 over 2 plus 1 over 3. Yes? So I get 3, 6 plus 2, 6 is 5, 6 plus 6, 6 is 11, 6. Okay? All right, we're starting to get the hang of it. This one's a little bit different. Notice there's no k involved here. There was a k in here, there was a k in here. So regardless of what k is, so k is 1. What's my first term? 2. Plus, what's my second term? 2. What's my third term? 2. What's my fourth term? 2. What's my first term? 2. So I have 6 2's. This equals 12. Okay. So that's sigma notation. All right. All right. Let's take a look at some properties of sums. So if A1, A2, A3, all the way up is a sequence, and so is B1, B2, B3, all the way up, those are sequences. Then for any integer n and real number c, the following rules apply. What do these rules say? If we sum two things that are being added, well, that's the same thing as adding up the first one plus adding up the second one. And if we sum up a difference of two sequences, that's the same thing as adding up the first one and subtracting the sum of the second one. Okay? And finally, if I sum up a number times some sequence, I can take that number out in front, find that sum first, then multiply it. Guys, this is just using the distributive property, that's all it is, and then also using the associative property and regrouping things. I can do this two ways. That's what this says. You can do this two ways. Okay? One way is you can say, okay, look, k equals 1. What happens if I get k equals 1? I get 2 times 1 plus 1. Very good. Now I put k equals 2 plus. This is k equals 1. K equals 2. I have 2 times 2 plus 1. Good. Plus. K equals 3. 2 times 3 plus 1. Awesome. K equals 4. 2 times 4 plus 1. Right? And then finally, k equals 5. 2 times 5 plus 1. So you could add that up. Or, equivalently, you could rewrite this expression as, the first thing you could do is you say k equals 1 to 5 of 2k plus k equals 1 to 5 of 1. That's what this rule right here says. Okay? You can break it up. And then this third rule says I can take that 2 and pull it out front. Okay? So then here, what I'm really looking at is 2 times k equals 1, 2, 3, 4, and 5. So I'll have 1, 2, 3, plus 4, plus 5, plus, here I have the sum of 1 plus 1 plus 1 plus 1 5 times. Right? Well, these two sums turn out to be the same thing. That's what this is trying to say. is it doesn't matter which way you do it. So here I get 5, 10, 15, 30 plus 5 equals 35. Should be the same thing here. 3 and 5, 8, 8 and 7 make 15. 15 and 9 is 24. 24 and 11 is 35. Okay? Doesn't matter which way you do it. Okay, so that's just rules of how we can work with sums for each of the different sequences. So the sum of a sequence can be broken up, the sum of the difference of the sequences can be broken up, and the sum of a scalar or a product, the scalar times the sequence, pull out the scalar.